All right, so we're gonna start with a couple easy ones, and the example 4 is really the level you need to get to. Okay, we're gonna do a few examples after that. So number 1, you have the same denominator, 2x plus 1. So you add your numerator, 5 plus 3 is 8 over 2x plus 1. 2x plus 1 cannot be factored, so I can't simplify this. It just stays how it is. Okay, denominators are different. One's a 2x, one's a 3x, so I need to make them the same. The only way you can change them or make them the same is by multiplying them by something to make them the same thing. So I can't multiply 2 by anything to make it equal 3, but I can multiply 2 by something and 3 by something to make them equal the same number. So what I want is them to have the denominator of 6x, okay? So to make, because 2 times 3 is 6 and 3 times 2 is 6. So you can multiply 2 by something to get 6 and 3 by something to get 6. So this is going to be their common denominator is a 6x, okay? So I multiply 2x times 3 to get a 6x. So I need to multiply the top by 3 as well, okay? So replace the bottom with 6x, and now 10 times 3 gives me 30. So now I've replaced the top with 30. So I now have 30 over 6x minus, and now we're going to do it here. To get a 6x, we had to multiply 3x times 2. Replace that with 6x. Now if I multiply the top by 2, I get 16. So minus 16 over 6x. 30 minus 16 is 14 over 6x. And 14 over 6 simplifies to be 7 over 3. So we get 7 over 3x as our answer. Okay. Down here, denominator is the same. So 10 minus 5 is 5 over our denominator, 8x minus 3. This one cannot be simplified because you cannot factor 8x minus 3. There's not a GCF. Okay. So now we're going to start example 4. Not hard, but this is more of the level we need to get to. Okay. So example 4, the denominator has already been factored. Okay. But here's where you want to be careful. You don't want to say, oh, I have an x plus 6 up here. I can cancel that with that x plus 6, because now your denominators are no longer the same. So when your denominators are the same, you want to go ahead and add everything together and then see what can simplify, or if anything can simplify. So denominators are the same, which means I'm just going to add the top. So I'm going to add my x's together. 1x plus 1x would give me 2x. And then a positive 6 plus a positive 4 would give me 10 over x plus 6 times x plus 3. Okay? You can leave it like this, or you could simplify it out. You could factor 2 from both of these, but a 2 wouldn't factor out with anything. And the top's not going to factor out either. If I factored it, 2x divided by 2 would be x. 10 divided by 2 would be 5. And an x plus 5 isn't going to cancel with an x plus 6 or an x plus 3. So it'd stay as a 2x plus 10. And then you could multiply this out to get an x squared plus 9x plus 18. Okay. I would accept either answer. Example 5. Let's put this down. Okay. Example 5, just like we said before, you want your denominator's the same, so you want to keep it the same. So you want to add or subtract, this one's subtract these together and then simplify, okay? So remember, when this is subtraction, this subtraction gets distributed to both of these terms, okay? So really what I have here is I have an x squared minus, I don't have any other x squareds, so I'm just going to bring my x squared down. Then I have a 6x minus a 2x, which would give me a positive 4x. Then I have a 5 minus 2, which gives me a positive 3. Over my common denominator of x squared plus 5x plus 4. Okay. Now from here, I would want to see if I could simplify. So I would want to factor both the top and the bottom to see if there's a common factor. Okay. So I'm going to factor at the top first. I'll do it on top. And then I'll factor the bottom second, and I'll do it on the bottom. So over here we have a is 1, b is 4, c is 3. A times c is 3, and my b is 4. So the only things that multiply to be 3 is 1 times 3. My a is 1. So we're just going to factor this top to be an x plus 1 and an x plus 3. Okay. Now, so I replace this with its factors. Now I'm going to do the same thing on the bottom. So here my a is 1, my b is 5, and my c is 4. 1 times 4 is 4, and then my b is 5. So I have 1 times 4 or 2 times 2. The only ones that would multiply to be 4 and then add to be 5 is 1 and 4. So we're going to factor this to be, and then my a is 1, so I don't have to do anything extra. So it's going to be x plus 1 and x plus 4. So I do have a common factor that would cancel out here, and it's the x plus 1 on the top and the bottom. So that leaves me an x plus 3 on top and an x plus 4 on the bottom. And my pen's running out of ink. Hopefully y'all can see that. So x plus 3 over x plus 4. Okay. All right, last couple of examples. So once again, denominators are the same, so I want to leave my denominators, and I just want to subtract or add the numerators to the top. So 4x, remember you got to distribute this minus sign to both of these terms. So 4x minus x would give me a 3x, and 9 minus 15 would give me a negative 6. Over my common denominator of x squared minus 2x minus 3. Okay, so I want to factor both the top and the bottom to see if there is any common denominators. Okay, so my two terms, my binomial on top, 3x minus 6, with two terms, all I can do is find the GCF. They don't both have an x, so we're just going to look at 3 and 6. 1 times 3 are the only factors for 3, so the only ones that they could have in common. Well, 2 times the 3 gives you 6, so they're going to have a GCF of 3. Okay, so if I take 3x minus 6 and I divide it by 3, or factor out of 3, then I would have my GCF up front. 3x divided by 3 would just leave me an x. And then a negative 6 divided by 3 would be a negative 2. So I've rewritten this factor to be 3 times x minus 2. And now I'm going to factor the bottom. So my a is 1, we like that. B is negative 2, c is negative 3. So 1 times the negative 3 is 3. My b is negative 2. Only things that multiply to be 3 is 1 times 3. Since I have a negative down here, I know 1 would need to be negative. It's going to be your 3. Using 1 and a negative 3. So we have factor this to be x plus 1 and then x minus 3. And it looks like nothing simplifies. Okay? Sometimes that happens. Sometimes it doesn't. If this had, say, been a 2, then we could have canceled those out, right, and had 3 over x plus 1. But these factors are different, so we're going to leave our answers at 3x minus 6 over an x squared minus 2x minus 3. All right, denominators are the same, so we keep our denominator. We're just going to simplify the top. So that's minus, so once again, I'm distributing it to everything. So x squared minus an x squared, we'll just make them cancel. Now I have a negative 2x minus a negative 4x. That might sound kind of confusing, so you can write it out. Negative 2x minus a negative 4x. Well, minus a negative would make that a plus, so we get negative 2x plus 4x. which is a positive 2x. And then 6 minus 2 would be a positive 4 over our common denominator, x squared plus 7x plus 10. Okay. Now we want to factor once again the top and the bottom to see if something will simplify. Okay. This one does simplify. Another one before did not. This one will. Okay. So let's look at it. I'm going to look for the GCF of 2 and 4. Some of you may see it right off and know they're both 2 and 4 divisible by 2, so their GCF is 2, but for those of you that don't, we'll write it out. They don't both have an x, so I don't have to worry about that. But things that'll multiply to be 2 is 1 times 2. 4, we have 2 times 2, which means their greatest common factor is 2. So I'm going to factor a 2 out. Okay, so 2x plus 4 divided by my GCF of 2. 2x divided by 2 would leave me just an x. And then 4 divided by 2 would leave me a 2. X squared plus 7x plus 10. X box. So you get a is 1. Alright, so then we have c is 10. 1 times 10 is 10, b is 7. So you have 1 and 10 or 2 and 5. The ones that add up to be 7 would be 2 and 5. So we would have x plus 2 and an x plus 5. Okay. We do have common factors that we can cancel out, leaving us a 2 over x plus 5 as our final answer.